Okay, so we're going to talk about measurements and error now. So the first point I want to get across, all measurements have error associated with them. We can minimize it by using better equipment, and basically we just throw money at it. So for example, this tape measure I've been using, it measures in inches because, it's a construction tape measure in the United States. It wouldn't be very helpful if it measured in centimeters, because all of our wood is like 2x4 and 4x8 and whatever it is, which really, it means 1.75 by 3.75 because of tolerances and stuff. But anyway, it has little markings on it, and so there's inches. And if I bring this out far enough, it's got the little dummy markers as well for feet, so I don't have to be like, oh, every 12 inches is a foot. I can just go, oh, there's a foot and an inch. See? Look at that. Stanley knows what they're doing. They know their market. It's this country. People don't like to do 12s here. Alright, and so between the inches, get something that's a little finer tip here, we can measure every half inch, quarter inch, eighth, or 16th. So this has a precision of a 16th of an inch or so. We could estimate between it. But that's our smallest marking. And so as we get more and more precise, we're minimizing our error. So precision and accuracy are different. Just a heads up on that. So accuracy is like, is this actually an inch here? Whereas precision is how small of a fraction of an inch can I measure? That's the difference. Just a heads up. I've argued about it on the internet. This is serious business here. And yes, I actually have argued on the internet. And I probably won, because the other guy was really old, so he's probably not alive to argue back anymore. And that's about the only way you can win an internet argument. If he is around, I'm sure he's come around to my way of thinking anyway, because I was so persuasive in those internet forums. I even, posted links and supported my argument with books, but whatever. Who reads? Okay, so 16th of an inch, eighth, so on and so forth. So you can use other tools to get even more precise measurements. You can use a laser tape, and you can get within 1/100th of an inch. There are ones that go within 1,000th of an inch. You can use micrometers, measure to the 1,000,000th of an inch. All of those tools are more expensive, and you have to ask yourself, do I need to know the dimensions of this room to the 1,000,000th of an inch? Or is a 16th going to work? And a lot of times I'm not even using every mark on that tape measure. I might just go nearest quarter of an inch, or so on and so forth. The saw cuts, and not like anything in my house is square anyway, so a lot of times I have to adjust from the measurement. And then there's the error of me reading the tape measure. Every now and again, things jump an inch or half an inch, one way or the other. Happens to the best of us, and the worst of us, like me. So, every measurement has an error, and that error is associated with, well, how large is it? Well, what kind of equipment are we using? And generally, the more expensive the equipment, the more we're reducing that error. And it just becomes a trade-off of, is it worth spending the money to get that higher level precision or not? So, whenever you have markings, we're going to simplify this a little bit. We're not going to go quarters, but we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all evenly spaced. So every one of these is a tenth. I can estimate between them. And so I'm always able to estimate one more decimal place than my markings, because I can be like, if I'm measuring something at this spot here, I can go 1, 2, 3, 4, 5, 6, 7, and we'll say this is just a whole 1 here. That's a whole 0 there. And so this spot right here, well, that's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, not 0.7, so it's 0.6, but it's clearly more than 0.6, and that's a little more than halfway, so I want to say 0.66 of whatever units these are. And so we can estimate that last number. We can estimate between our markings. So we always have one more decimal place of estimated precision than our instrumentation gives us. And so this would be accurate to the nearest 100th of whatever this is. We'll call them made-ups or something. Whatever. So, all measured values have errors. That is what I've spent the last, 5 minutes talking about. And no, you don't get that time back. So all measured values have errors. We can't avoid the error, we can only minimize it. So how do we account for this? Well, that's going to be what the next video is all about. That's going to be significant figures. So I have ignored significant figures to this point. But I don't want to report a more precise value than I've measured. So my measurement limits what I can say. If I measured, this value and I do some math later and say something with like 10 decimal places in it, that's probably not legitimate. I've been limited by this measurement. We're going to talk about what that means. And the mathematical tool for doing that, the accounting tool, is significant figures. So that's what we're going to talk about next. But this idea that all measurements have error, precision is just how far, and we're going to talk about that more in the next video too. How far can I go? Accuracy, if I say that's an inch, is that accurate? Well, let me check against a known standard. No, that would not be very accurate. It is about, 3 3/4 inches or so. But that would be a terrible, inch-long ruler. Or, maybe it's a foot. Well, not quite a foot. A foot is off the scale there. So it would be very inaccurate, but it does have a level of precision to the 100th of whatever it is. So these two ideas are not the same. We use those words interchangeably in our everyday language, but scientifically and mathematically they are not the same. Statistically not the same. Alright, so we're going to talk about significant figures next. And what it all boils down to is just the fact that all measurements have errors. And we have to account for those errors as we carry calculations through with these measured values. That's what we're doing. So there's going to be rules. We're going to talk about rules. But all it comes down to is keeping track of our level of error. That's what's going on.